Hello, everybody. In this video, we are going to go through our lesson, quadratic transformations. And to begin with, I want to start with a key idea, and that is that a function transformation it changes the graph. It slides, reflects, and or stretches or compresses it in some way. And what is it stretching or compressing? A parent graph. So a function transformation slides, reflects, and/or stretches, compresses a parent graph. So if we're working with quadratic transformations, what is the quadratic parent function? Quadratic parent function. And this is as simple as a parent function can come for a quadratic, and this is y is equal to x squared. Or we could see this as f of x is equal to x squared. And this creates a parabola that is pointing up. So here's my x-axis, and here's my y. So this graph has a point on the origin. This is the point 0, 0. We also have the point 1, 1. We have 2, 4. And then we have these points mirrored on the opposite side. Oop, that's kind of too high up, but that's okay. So this is our quadratic parent function, a parabola sitting right on the origin, pointing up. So these are some of our common points. We then also have the opposites, right? We have like -1, 1, and -2, 4. Now, how can we transform this? We have three main types of transformations that we will be working with. So the first type of transformation is a translation. And a translation slides or shifts your graph. And it's going to slide or shift horizontally and or vertically. So if it is going to slide or shift it horizontally, that means it is going either to the left or to the right. If it is shifting vertically, then it is going up or it is going down. You could go left and down. You could go right and up. You can't go both up and down. You're going either up or down. So that is a translation. And a translation, oftentimes when you are looking at that parent function, you are going to add or subtract values from inside the parentheses or outside. And we'll talk about what this means right now. So if you want to shift your parent function up k units, so you want to go up k units, you are going to take your parent function y equals x squared, and you are going to add k outside of the x. So you are either adding or subtracting values from inside with x or outside the function. So this is outside. If you're going up or down, you are directly affecting the y values, the function values. So you are going to be outside of that function. Oops, I don't know why I switched that. If you want to go down k units, then your parent function y equals x squared, you are going to subtract k from it. So either way, if you are going up or down, you will take your f of x, your parent function, and you will add or subtract the k units that you are moving vertically. So shift vertically, meaning up or down. Now let's say we're going to shift horizontally. So maybe I am going to go to the right. H units. I'm going to use a different letter because I could also be going up or down some k units here. So now we are directly affecting the x values. So this is going to be inside with x. So to go right h units, inside with x, I'm going to subtract h, and that all is being squared. So y equals x minus h squared is going to move my graph right h units. And then if I want to go to the left h units, then inside with x, I am going to have h added. So I have y equals x plus h squared. So up above here, when we were moving up or down, we added k outside. Now, if we are going left or right, we're moving horizontally. I am going to inside with x add or subtract my value. So inside with x is going to affect our x values. It's going to shift horizontally. Horizontally. All right, so these are all of our translations. They are just adding or subtracting values either with x or outside of it. Now, let's talk about reflections. So another type of transformation is a reflection. And a reflection flips the parent function across the x-axis or the y-axis. So what does this look like? Usually you're going to be making the inside or outside negative. So make inside or outside of the function negative. Now again, we're just working with this same parent function. So if you want to make a note again, the parent is f of x is equal to x squared, or y is equal to x squared. So if I want to reflect across the x-axis, so across the x-axis, remember the x-axis is your horizontal axis. So any point that was above is now going to be below. Any point that was below is going to be above. So what we will do here, if we are affecting whether it's above or below the x-axis, we're actually changing the heights or the y values. So I'm going to make the outside of the function negative. So this would be y is equal to negative and then x squared, right? It's almost like this is in parentheses, but it doesn't need to be. So this is like negative f of x, essentially. Just taking the function, making it negative. If we are going to go across the y-axis, let's do this color. Our y-axis is the axis that is straight up and down. So a point that was perhaps on the left is going to now flip over to the right. So now I'm affecting those x values, right? This is what we call a horizontal reflection. Whereas reflecting across the x-axis is a vertical reflection because we're changing those y values. So if we are affecting those x values, now my negative is going to be in with the x. So reflecting across the y-axis, the equation for this would be y is equal to in with x, a negative. So negative x squared. This is really like f of negative x, taking our function and making just the x negative. This graph is the same as the original parent, just for the quadratic, which is fun. Okay, so those are reflections. You're adding a negative either inside or outside. Now let's talk about that stretch or compress. That's kind of our final one. What color am I gonna do? Green, I guess. So stretch or compress. So if you are stretching or compressing, this is kind of like dilating. You are really changing the speed at which your graph is growing. So this stretch means that we are either pulling it out horizontally or vertically, or we are shrinking it. We are compressing it down horizontally or vertically. So the general strategy here for this is going to be to multiply by a whole number or a fraction. And you're either going to multiply inside or outside. Now, in Algebra 1, we are normally going to be working with vertical stretching and vertical compressing. So let's start with that. If we have our parent function and we want to stretch f of x or the parent function vertically, that means I'm going to take it and I'm going to pull it both directions up and down. I'm stretching it out. And essentially what's going to happen, and actually I'm going to write it kind of like this. Essentially what's going to happen is our parabola is going to be a lot skinnier. So the way this will happen is if we take this x squared and we multiply it by some value a. So if I have some a x squared, where a is bigger than 1. All right, now if I want to shrink my graph vertically, that means from the top and from the bottom, I am pushing it in vertically. Always working vertically here if it says to. And I should have switched colors. But if we're going to shrink vertically, we are pushing it in from the top and the bottom. And now this is still just going to be y is equal to ax squared, but now a has to be some number between 0 and 1. So I'm going to say 0 is less than a, which is less than 1, meaning it's between 0 and 1. So maybe this is 1/2 or 0.2 or 0.75. Both of these are going to shrink, or any of those are going to shrink your graph vertically. Now let's talk about the horizontal. In both of these yellow stretching or compression scenarios, we really just had f of x being multiplied by a. right? And that's going to affect it vertically. Now let's look at horizontally. So if I want to stretch horizontally, that means I'm going to take it and stretch it to the left and to the right. So now I am pulling it sideways and pulling it out. So think about taking the parabola and pulling it outwards. This is going to happen by taking our parent function and multiplying just x by a number. So I am going to multiply in parentheses a times x squared. All of it's being squared now, and the a is inside with x. We're affecting those x values working horizontally. And a here is between 0 and 1. So to stretch your graph horizontally, you're going to multiply a in with x, and a is between 0 and 1. If you are wishing to shrink your parabola horizontally, that means from the left and from the right, you are trying to push it in. That is going to happen if you have y is equal to, in parentheses, ax squared, but a is bigger than 1. And again, these horizontal ones are less common, but if you are stretching or compressing horizontally, you are going to multiply some number in with x. This is like f of a times x. And if a is a number bigger than 1, it's going to shrink horizontally. And if it is larger than 1, it is going to stretch. Or sorry, if it's between 0 and 1, it's going to stretch horizontally. Okay, so in my next video, I'm going to go through some examples with this. So please finish writing all of this down, kind of soak it in, and then write down the examples in the next video.